So this question says that a bomber is flying in level flight with constant velocity and releases a bomb before it's over its target. Neglecting air resistance, which of the following is not true? So let's look at our 5 answers and go through them one at a time. First question says that the bomber is over the target when the bomb strikes. Well, we know that these are kinematic problems. We can just see constant velocity, it's over a target, it's flying at level flight. It looks like when it drops a bomb that the only thing that's happening on this is that there's going to be an acceleration due to gravity. So our equation, x equals x naught plus v naught t plus 1/2 at squared, says that as we release the bomb in the x direction, in the horizontal direction, part that would tell us how far we go over the ground, that the velocity of the bomb and the velocity of the plane are going to be the same. However, there's going to be no acceleration in the horizontal direction because we're neglecting air resistance. So assuming that the bomber keeps level flight and we're keeping a constant velocity, once the bomb is released, that velocity, that horizontal velocity it has, is not changing. Neither is the bomber. So they're going to be going in the same horizontal position and checking off the same amount of time every second, or the same amount of distance every second, that this one is going to be a true statement. We're looking for a not true answer. So the bomber will be over the target when the bomb strikes. The bomber will always be over the bomb, actually, for the entire process. Second one, the acceleration of the bomb is constant. Well, we actually kind of mentioned this. The only acceleration in this term is acceleration is equal to minus g in the y direction, assuming a coordinate system of up being positive y. So this one is a true statement as well. I'm going to skip the next one because it's actually kind of a hard one to go through. So horizontal velocity of the plane equals the vertical velocity of the bomb when it hits the target. That sounds like it's going to take us some work. So let's see if we can't actually find a false statement in the next one. The bomb travels a curved path. Well, this is the equation in position for both the x and the y coordinates. The x is going to be a linear function. The y is going to be a parabola. The track that it's going to do is actually going to be a parabola. Parabola is a nice curve. The time of flight of the bomb is independent of the horizontal speed of the plane. In a lot of these kinematic problems, the time that it takes for the bomb to get from where it starts to the ground is actually what determines how long this problem lasts, how much time is traveled. So the horizontal speed gains nothing because we stop our clock when we hit on the vertical, when the bomb hits the ground, which is vertical. Doesn't matter where horizontally it works. So C must be the right answer, just because we've eliminated everything else. So let's go back to this one. It says the horizontal velocity of the plane equals the vertical velocity of the plane. This means that the horizontal velocity of the plane is equal, and the horizontal velocity of the plane is the horizontal velocity of the bomb. No acceleration in the horizontal direction, so its initial horizontal constant velocity is going to be the same for the plane and the bomb, and it's never going to change. So our horizontal velocity equals our vertical velocity. So that would make this thing have to land at a 45-degree angle. Well, there's no reason that that has to happen. We could have, the bomb is going to follow this parabolic path. If the bomber was really close to the ground, then up here we're going to have horizontal velocities all the same, but over here, small little it, and they were going to eventually get larger and larger vertical velocities, more in the negative direction, and this is because the acceleration happens in that direction. So there's no reason that says that we have to be at 45 degrees, so that they have to have the same value. So C is a not true statement. It's our correct answer.